part of this really cool community that is developing the little program cards that go in here. So I've made a bunch of them. I just was doing inventory based on my YouTube admin memoir. I guess I made 5. And they're kind of indicative also of what this is and some of the breadth of what it can be, which is where I wanted to start today. So we're going to talk a little bit about what is the computer, what are computer cards, and then we're going to dive in and talk about what computer card do we want to make in this room. And we're going to design it together and probably debate and spend some time doing that. And then I'm going to do some show and tell of how I might at least start developing that card. And then I hope to actually build it and finish it before I leave here. We'll see if that happens. So let's start with what the heck is it? So this is like recap. You guys have all seen it. You've all messed around with it at this point. But the leftmost piece on the workshop system is the digital part. It's the only thing that's digital. And it's this do whatever you want system that is powered by a chip called the RP2040. RP stands for Raspberry Pi. It's like the same company, I believe they're from the UK. And it's a great chip because it's powerful. And I assume that the name means they're going to support it until at least 2040, which is good news. It can do all sorts of things. In a traditional computer that you would incorporate the chip into, you would have a complete computer that serves some kind of purpose in an embedded environment. So you'd have you imagine something like, I believe the Ableton Move actually has Raspberry Pi in it. It's maybe a more powerful one, but it serves the purpose of there's a whole ecosystem of companies that will take these chips and put them in their products and design a whole thing around it. So what's weird about the computer part of the workshop system is, and Tom was talking about this a bit before, but is that traditionally a computer has RAM, which is your random access memory that you use to work in your working memory, and then you have longer term memory in flash. And that contains everything you need to run the operating system, to store things, to do all that. So without these cards, the computer part of the workshop system doesn't have any flash, and therefore it doesn't really do anything. It's kind of an incomplete computer. And so the idea, a brilliant idea, I would say, Tom, is you get these little cards, you complete the computer, you put whatever you want on these, and then you get to decide what the computer does. And so you've seen a bunch of examples of this already this week, hopefully, but it can do everything from blasting through the things I made from right to left. It can be a looper delay thing where you send audio in and you get little bits of audio back. It can be a chaotic oscillator / modulation source that sounds like cats fighting. It can be a beautiful music theory informed songwriter that will help you transpose around the circle of fifths like Coltrane. It can be a weird granular processor that takes audio in and then slices up into teeny tiny pieces and spits them back out at you. And it can also be a platform that you can use to write code in a way that's more accessible to folks who might not be as interested in getting deep into some of the coding languages that we'll talk about today in terms of C++ and that kind of thing. That was the idea behind the last one. And then obviously there's I think 80, something crazy like that, cards on the GitHub that folks from across the community have made that do all kinds of things, from generating light shows to playing back the sound of rain in one's backyard, and kind of everything in between. So what can it be? Well, the sky's kind of the limit. There are some limitations. And there are technical limitations, but those are no fun. So we're going to talk about the the limitations that you can see on the page, and by the page I mean the whiteboard here. The biggest limitation of the system is the ins and outs and the interface, I would say. And I guess I didn't draw the LEDs there, but I probably should. Whatever it is that you make, all you get to interact with it is one big knob. I'll draw a little thing, make it clear. Two little knobs, a switch with 3 positions, and then you have your ins and outs, and you have 6 LEDs. That's your screen. And you also only have 6 pairs of ins and outs for audio, CV, and gate. But they add up, or you run out really fast because you only have 2 of each. And so while the technical, there's limitations to what a small chip like this can do, there's, I think, bigger limitations in terms of what the experience is and how can you design something that is, makes sense to the user if that's what you want, or at least is fun to use and maybe creates interesting musical results. And so what I wanted to do is, ask you guys, turn it over to y'all. Yes, I'm Canadian, but I've reclaimed y'all. My wife's from Mississippi. Y'all's great. You should try it out. What I wanted to do was ask you, you've all used the system a bit this week already. What is it that if you were to cover the computer section, you feel like you miss the most? And or what's your crazy idea for a thing that we could do with the computer that we haven't done yet? And then I want to kind of just brainstorm. And I will call on individuals if nobody talks.
I'm assuming in the 80-card library somebody's introduced noise and random modulation.
Forget about anything that exists already. It doesn't matter what's already been done. All that matters is what you might consider making.
It would be nice if somehow you could put an image of a graphic score in it and it would just output music.
Really? Okay. Hey, we're writing it down.
We're done.
Image of score.
Image to music.
Yeah, right.
Yes.
Sound map's easy.
This is.
I want to put in a photograph of my cat or my baby and turn my baby into a musical piece.
Okay, score in, music out. That's idea 1.
Given the place-based nature of this residency and the island and the weather that we're protected from in this building, I'm really curious about slow-moving natural modulation sources.
Okay.
So I mentioned earlier, what if we could do weather sonification? Or I saw Mark had printed out and was thinking about prior to the residency, drifts or lake currents. So natural data set to modulation.
Interesting. And I know I gave you.
I think that's more articulate.
I gave you secret homework to try and find some data that we could use. Did you happen to do that? If not, no worries.
I saw this printout that you had.
I haven't shown you the printout that I have, but have I done homework?
You have a printout. That's more than, yeah.
I do. I have a few printouts of ideas.
Cool.
We talked about one in the previous group with Phil, who's sitting behind you.
Yeah.
I was looking at, one of the ideas was GPX to track and try and use the GPX file for creating MIDI and stuff like that. But I guess, there are things, a walking GPX may be a little dull, but as a cyclist, I will do a training loop and I'll do hill climbs, and so there's acceleration and there's altitude and all other little bits and pieces that could possibly be captured. I'm not sure.
Mm-hmm.
I think another one of the ideas was around geological strata,
Cool.
things like that.
What does that mean to you, geological strata?
Um,
Or should I just say, what should it mean to me? I don't know what it is.
To you, had the various components of rock formations. So you have graphites, you have gneisses, you have limestone. And when you look at a geological map, they have particular maps, like the moon even has a map
Yeah.
of all the different types of minerals that you can be found. So it's sort of, I guess it's like taking an image and maybe scanning across an image with some device, whether it's a camera or whether, I'm not sure. Maybe there's even stuff that you could pull from NASA satellites that sort of has detected those mineral types.
Okay.
It's vast. I mean, there's a treasure trove.
The interesting thing is that you kind of got back to score in, music out, which
I have an idea along this. So Jason Nolan, who I think played a part in making this all happen, I saw him post a news story recently where they got a bunch of audio files together.
yeah.
Like people who really like fine, high quality, expensive sound.
Mm-hmm.
And they ran a series of listening tests where they ran the signal through like $10,000 speakers and the best wire.
Mm-hmm.
And then they ran the signal through a banana.
Mm-hmm.
And then they ran the signal through dirt. And the audio files couldn't distinguish between the different sounds.
Yep.
So, okay, can we take a sound and run it through an image file, using the image file to distort the sound somehow?
Mm.
Oh, like spectral or something.
So sound in,
Sound out.
score out, score in, music out.
Yes.
I like this. We can do this. This is all very achievable.
Because the image thing does make me think of like analyzing the image in some way and then using that to somehow like transfer the audio.
Have you seen that pedal that Game Changer has coming out, where you record an audio sample and then use that as a means to process another sample? So like it becomes the sort of spectral lens that you process that audio through. So that could be another similar thing, right? Like a
Interesting.
micro loop that you then use as a filter or something.
Okay, before we go further.
There's
Oh,
a
wait.
really old piece of software, which I think was called Photosynth, but it might not have been before that,
Mm.
where you would put in like a JPEG,
Mhm.
and it would treat that as a spectral file with the frequencies.
Mm-hmm.
So it would create these amazing kind of very rich and weird sounding sounds just by playing them. So you essentially use the photo as the oscillator.
Yeah.
Aphex used it, obviously, but it's a really amazing sound.
Okay. Very cool.
So one of them, please.
Before we go, absolutely.
Yeah, please.
Before we go further, does anybody absolutely hate this idea? You all have veto power. Okay, cool.
Could you do an attenuator, please?
Oh, an attenuator. Oh, yeah.
Yeah, I could have a VC.
Yeah. Before we zone in too far, like, I want to give folks like Kirk. What is there something that you were like, man, I wish it did this, or I wish the workshop had this?
I mean, we were kind of joking about like a proper VCA.
Cool. It has to have a VCA.
Storytelling.
Done. We're putting it on the list.
I guess like a utility card just with
But a more serious answer, I would just think, brainstorming, what about some way to plug in like a controller or something, like a game controller, use it
Oh.
as you move it around, output some sort of modulation, like a joystick module basically.
that's good.
On that subject, on your diagram you haven't got the MIDI,
Oh, you're right.
and I'm just wondering, is that allowed on your diagram?
Yeah, absolutely. Yeah.
The USB-C?
I forgot about it.
USB-C, yeah.
My diagram is kind of not to scale anymore, but this is a.
But that can be used?
Yeah, absolutely.
And what can that be?
So the USB port, that's a great point. The USB port on the system can be, again, the sky's kind of the limit, but the things that have been explored so far are definitely MIDI. You can have it so that either you plug the system into a computer and you plug a controller into the computer and you control the system that way, or you can have it so that you can plug a controller right into the system with the right cable. And with the right software, you can have it, if it's a small enough device, powered by the USB on the device and then also controlling it. And then it can also, I think we've done, oh man. I think hardware, human interface devices are pretty doable. I'm not sure if somebody's already done it, but that would be like oh great, sorry. Keyboard and mouse.
I'd be really interested in a keyboard.
Yeah.
I don't know what you use it for, though, but the idea of just plugging a keyboard in and what can you do with whatever 80 buttons?
Yeah.
Whether it's like 16-step drum sequences or something you do with it. I think that might be interesting.
Yeah, yeah.
You almost have to work out what you're going to do with it
Mm-hmm.
before you do the easy bit of the...
Yeah,
And a mouse for XY would be interesting as well.
it would. Yeah.
You can implement Music Mouse
Yeah.
with those two.
Yeah.
How would that differ from, say, using grid from one?
I don't have a group.
Plus, the grid buttons don't have letters on them.
Right.
Do you have lights, though?
They do have lights, which some fancy keyboards do as well. Okay, any other ideas that people want to throw out there before we dig a little deeper? I'm going to go into PM mode so that we can squash feature creep a little bit before we proceed. However,
You're going to load it into Jira.
we don't have time for that.
Is something like the Pocket Sci-Fi, I mean, I know it does MIDI out there, so does OSC, does that add any value or not?
What would you like it to do?
I'm not really sure, it's just generating, again, it's just generating a huge volume of information that
Mm-hmm.
could be culled. I mean, so you would need some sort of gatekeeper
Yeah.
application
Mm-hmm.
that
Mm-hmm.
somehow just says, okay, enough, or we want to push it in this direction.
Yeah.
I think it just feels like all these things out there with, yeah, ton of information, but it all seems to have to, you need to gatekeep it somehow, so I'm not quite sure how, but it all seems to come back to that.
Okay. Any other thoughts before we dive in? Gabe?
Music out, is it audio out or is it CV plus gate?
The which one? Sorry.
Music out, the last output, is it audio or is it CV plus gate?
In your diagram at the bottom. The diagram at the bottom.
Not specified.
Could be music, could be...
Maybe both.
Oh,
Could be both.
Yeah, we're gonna have to constrain it to this eventually, which will be hard.
yeah,
But
because it
And
has
the audio,
We have
is the audio
some
DC
of
coupled?
each, yeah.
Gabe,
Doesn't it have audio out?
it does. Yeah, so it could be just straight up audio, or you could, one thing that I'm always thinking, trying to make these things for the system, as you guys have used, is figuring out, trying not to re-implement anything in the system that's already there some other way. So I don't think I have yet to code a filter, or I guess I did an oscillator, but yeah, VCAs are allowed. Take that, Tom.
Are the audio outputs DC coupled? Like, can they be
Yes.
So you can have 4 CVs.
Yes.
Okay.
Okay, cool.
You can't do audio on USB, right?
You can.
Mm-hmm.
Somebody made a 6-in, 6-out USB interface. Apparently it's one of the two on the market. Although it must be CD pulses in there.
All right. So this is the system that we're thinking about, that I'm hearing from you guys. We have some kind of file, and we are going to take that file, and we are going to, oh, sorry, I shouldn't have put that all the way to the left, because you have optional sound. So we can use an audio input to somehow generate some kind of file. And I'm going to put image. And then that is a requirement for producing our outputs, whatever those are. So my first question is, so if we wanted to support any type of file, we could do that, conceivably. Files on computers are just like numbers at some level. The downside would be you wouldn't be able to do kind of computer vision stuff that you might be able to do if you were trying to deal with an image. If we say it's specifically an image, then you could say, what's the picture of? Can we interpret the picture as if it's a picture of a frequency response or that kind of thing. Or we could crunch the numbers of whatever it is without caring too much and try and use that. What are your thoughts?
Well, you're limited to, you can only have 2 megs or 16 megs on the card?
Oh, no, don't worry about that.
Okay.
I assume we're going to build a web page, and the web page is going to have your file on it.
Okay. Well, yeah. No.
I imagined like crunching the data out of a JPEG. If I
Yeah.
give you a JPEG of a banana,
Mm-hmm.
can we run the audio through that?
Yeah.
I think the image seems like a really good place to start.
Yeah. All right.
But otherwise, it's basically just random numbers, isn't it?
It would be a bit more chaotic. I mean, it's probably going to be chaotic no matter
I
what.
mean,
But.
you upload a zip file of your code and you can make weird noises from it. But in the image, you could conceivably have sound matching the image in some intelligible way.
Yeah. Okay. So what I'd say is, why don't we start with this, and then this can be kind of tacked on, because we'll have 2 unused audio inputs that we can think about later. But I also think we could cheat a little bit with this part by having an interface that will be on your laptop in a kind of web experience. And that website would be allowing you to upload a file. So let's just like sketch out what we could do to do this. I'm gonna quasi-prescribe some of the preliminary stuff, but please jump in. Like, this is super conversational. You're all getting a writing credit on this shit, so. So you all get publishing rights.
Share of the profits.
Exactly, yeah. So the website is like file input, and like we'll need to show the image. And then what are the kind of things, maybe like,
So like if you were doing that photosynth thing,
yes,
you could say, right, we're going to do a 32-band sine wave kind of resynthesis thing.
Yeah.
And then all you would do is look at the image, resize it to 32 pixels tall,
mm-hmm.
do some kind of brightness or whatever for each of those pixels,
Mm-hmm.
and however long it is,
Mm-hmm.
and then send that to the machine,
Mm-hmm.
and then it would play back that sound file.
Yeah. So let's dive into the last part, because I'm wondering, because I want to know what you guys think. We could totally make it so it just does playback. I have a feeling that we can do slightly better than playback.
Like, I would think you process the image into some proprietary format, but then the card.
Oh, we'll sort that out. I'm thinking sound-wise. Like, what do you want to be able to change? Assume that you can get some kind of sequence or a modulation signal from the picture. What do you want to be able to change on the device itself? If you think about think about just the knobs first. So big one, 2 little ones, and a switch.
Big one could be zoom,
Zoom.
in and out of the image.
Gamma.
Yeah, like contrast and
Well, like an XY scan of a 32 by 32 box around this image.
Mm.
So you've got X and Y or X and Y.
For the 2 little ones, yeah.
that's cool.
They already.
That's
made
very
it.
nice.
Yeah.
That's why it's just sketch again.
An
They already
automatic
made it.
scanning
They are
across
already
would probably be
exit
nice,
Y.
but you could use the
I think, yeah.
use slopes for that, couldn't you?
Yeah. So one of our CV inputs maybe is like, well, I guess you could just modulate X and Y.
I think
That's what I mean,
Yeah. And we're going to leave our audio ones untouched for now. Sorry, I'm just like adding layers apparently without erasing. And so CV inputs would be X and Y.
What if it's a 32 by 32 pixel grid, can we use gate in to scan across and another gate in to scan down?
Oh,
Yep.
step through those
Yeah,
sections.
yeah, exactly. So like each step moves 1 pixel,
Yeah.
each step moves 1 pixel, and so
Mm.
that you could actually navigate a matrix 32 by 32.
So it's like in Playroom.
Exactly.
Yeah.
Down, enhance.
You could
So the main knob is called enhance.
Yes. Yes, it definitely
Oh,
is.
it does, but it's enhanced.
Yeah, fuck Zoom. It's called enhance.
And is there like a gate mode too that outputs, like when it sees a pixel? That
Yeah,
passes
well,
Yeah, that's what you use the pulse outs for.
Yeah.
When it
That's
sees,
sequences too.
And then if you put the pulse out into one of those inputs, it would kind of auto move around based on the picture, wouldn't it?
it would.
That'd be quite fun.
You were at lunch, we're showing that app that lets you put like filters
Yeah.
on video. Polycam? Like reminded me kind of the like filters that were built into Photo Booth.
Oh, yeah.
What if the like hitting the momentary switch with like page through 6 or 8 different like wacky presets that would change the image? Because I'm assuming we're
I wonder if just a really simple thing like that would just be inverting the image.
yeah, like
That would be a
inverting
really nice
and
immediate
colorizing it.
change.
Or
Yeah.
RGB channels?
Yeah.
Yeah.
Right, just only having the blue, only having
Yeah.
the green. Yeah.
Wait, you're not actually gonna,
No, I'm just going to start it.
AI's gonna do it?
I'm only going to start it on the website.
Oh, man.
Only the
I
website.
thought we were gonna program, I was camping on a new career and everything.
Oh, man.
I'm bringing the binary.
That really hurts.
That ship is sailed.
I'm just going to start it on the
We're still
website.
just talking binary, right?
Uh-huh.
Yeah, good,
Quite all right.
He's got quotas to hit.
I think there's like, isn't there like web APIs now that let you do that kind of
Sure, and I'm just going to let it do that. I'll explain later. We'll come back to it. I just don't want to spend time on the website part of it. So, a couple questions. This is really great. I think the open questions in my head are audio and CV out. So we have our 2 audio outputs and our 2 CV outputs.
And we have gate outputs.
And we have gate outputs. We haven't decided that either, I guess. So all our outputs, we haven't decided.
I wonder if you have some kind of image to audio generation based on how you're tracking across the image.
Mm-hmm.
You could actually conceptually have 2 windows on that image that are the left and right outputs.
Mm-hmm. Mm-hmm.
So they might just be next to each other, they might be offset or something, but you'd get 2
Yeah.
quite rich audio outputs.
Yeah, you could basically have a frame
That sort of thing.
that you move around that's kind of like this.
Yeah, exactly. And they're the left and right outputs.
Yeah.
It's simple.
Now, I wonder if you'd have things being too similar right next to each other so that the left and right would almost always be exactly the same.
If that happens, you just make it so it mirrors on the image.
Great idea. Yeah.
There could be modes for scanning and ops, like, ping pong modes.
Okay. And that's a metaphor we could use for all the outputs if we can figure out what one of them looks like. Each frame has 2. There's 2 frames that we're going to move around. Either they'll be right next to each other or they'll be mirrored, whatever. But we need to do audio generation based on the contents of the frame, and we need to do CV and gate.
So thinking in the workshop scenario,
Mhm.
you're going to want some CV that you could either use to control an oscillator or control a filter, or control something else within this.
Mm-hmm. Mm-hmm.
Right, like patch, program it back.
Yeah.
Yeah. But essentially like CV modulation of some kind, and if it were to interpret like gradient of pixel across a 10-point scale, something
Mhm.
like that.
So we can have, I think,
But that makes it basically black and white. I mean, we're basically taking an image and crunching it into a bitmap. Oh, no,
Mhm.
not quite, because, no, we'll still have grayscale.
yeah, I think each position just needs to be one voltage value, one 0 and 1 value, and one set of parameters for whatever audio thing we're doing. Probably not one sample.
So if we're doing the audio, a way of doing the audio would be to say, take a vertical column of pixels,
Mhm.
apply each pixel to the amplitude of a frequency, and resynthesize them, make a sound from that. I think that's what Metasynth
Mm.
does. You could then say, for example, average that pile of pixels, and that's your CV output, and then as you track across, the CV output's going up and down. Well, that'd be quite fast.
Mm-hmm.
I don't know.
I'm wondering if we could, maybe this is cheating because it's throwing away the, I'm gonna sit on the floor. Don't freak out. Hopefully my mic still works down here.
Tom has to sit on the table.
We could use, instead of putting a synth in, we could process the audio input, whatever it is, which would also add cool feedback stuff, potentially.
Yeah, like spectral processing that way.
Yeah,
And then something would happen if there was nothing plugged into
Yes.
it. Okay, that makes sense.
yeah.
And I have scope creep for the web part too, just a pixel editor where you can just draw.
Yeah. Oh, nice, okay.
You have a few, I mean, and also you have, it's more than just like light or dark too, like you have color as well. And if you want to compute the color into RGB,
Yeah.
then you could break things down into those three different variables as well.
Okay, I have a challenge / prompt for y'all. I said y'all again. I'm really into y'all. You all have been doing work with visual scores this week. What are you thinking about when you're looking at the score and trying to turn it into music? It's a big ass question. But
What means what?
as in, imagine that you upload a picture of your score to this tool. What kind of output would you like to have?
Well, it might be, maybe it's useful to have, as a part of the interface, the ability to decide which, like, or all of those parameters you want to influence either the sound processing or the audio generation. So like you could choose like, oh no, I only want to use, like, because I'm uploaded a black and white image, I only want to use, you know, how light or dark the image as the,
Okay, so eventually you could like use parameters
yeah.
to determine, to customize more. Yeah? Okay. What's the first thing you set the parameters to?
I don't know.
Okay.
I think it's like you said. It's just like what means what can I, based on what I have on the table, how do I
Yeah, I think the
correlate that to?
yeah, the thing I was trying to steer you towards is stop trying to think about it as a thing that a computer can do or can't do, and start trying to think about it as like, what are the kinds of things, and maybe we haven't done too much of it yet, I'm not sure, maybe some groups have, where you might look at a score and see an element of it and try and interpret that as a musical event, or something that we could like approximate potentially. Might be interesting.
Can it find shapes that would be loops or loop lengths or sequence?
Interesting.
So if it sees a square, it'll be a sort of square pattern, or if it's squiggly, it'll become like an allophode sound. The other thought was, if you're talking about the audio inputs that could affect it,
Mm-hmm.
could the still image actually be a video with sound?
Yeah. I'm not gonna shut it down.
4K image. 4K
Mhm. Yeah, eventually we will run up against the technical challenges, but we're not there yet. So hell yeah, right now.
But because if you look at the shapes that people have drawn, or if you look at the symbols from Tom's scores, there are some kind of standard shapes that repeat, right? Triangles, lines, diagonals.
Mm-hmm.
Could you just define one as a rising sequence, one as a looping sequence, a certain length? If it's a big shape, it's a bigger loop, something like that.
Mm-hmm. Yeah, I'm wondering if.
Is that the kind of question?
Well, is there like, maybe there's different processing modes here, like, if you're scanning it line by line to get gates, that's obviously one operating mode, but if you're processing the whole image into types of symbolic entities, then that's another processing mode, I guess, right?
Yeah, I wonder if you could generalize it so that it's like, if you're close enough, then all the pixels are squares, for example, and if you zoom out far enough, then you start to get things underneath.
So Pauline Oliveros talks about two types of listening, close
Mhm.
listening and global listening.
Mm.
Listening to everything in your environment, or getting real fine listening to like the ant on the sticks.
Mm-hmm.
So interpreting shapes across an image would be like kind of global,
Mm-hmm.
but then getting down into an individual pixel that you're like matrix scanning would be that kind of close listening, right?
Yeah.
So maybe this enhance knob is still, we're back to scale. Am I interpreting 1 pixel at a time, 4 pixels at a time, 16 pixels at a time, 32 pixels at a time?
Yeah, your enhance control is actually zooming out.
Revolution.
Yeah.
Resolution, right?
Yeah, interesting. Yeah, it occurred to me that we might also want to recognize letters and numbers because that could be fun.
Yeah, I'm
Can we
picturing.
pick one though?
Oh, we're gonna
We're gonna pick one.
pick one for now. Yeah,
I'm
yeah.
picturing like you could have a webcam and like live play the sequencer. Potentially, like you could snap it at.
That would be really cool. Yeah, here's what I'm thinking. Picture that you upload to Flash and is static, very doable. Picture that does a bunch of processing on the website side and then sends some messages that we define to the device and can update quasi-live, probably also doable. That would require you having the website open while you're playing, which I think is to me that's an acceptable constraint. I don't know. Without it, it wouldn't make much sense.
Yeah.
Because it kind of has a screen, which I kind of like because I know it pisses Tom off. And then if we did that, it's only really a step further to, okay, it's a video feed and all the crunching's happening in the browser and we're still just sending some kind of minimal messages to the device.
Can we think about the 3x2 screen on the device?
Mmm.
Oh, you could scan around it.
Scan your pixel, display the image on there.
Yes.
Well, that could, it could at least,
That's a great use of the
keep
screen.
track of where on the X and Y axis you are.
Oh, that's
based
true.
on like the brightness of the LEDs maybe.
Oh, yeah, that's cool, yeah.
Do the LEDs have brightness
I don't
control?
know
or
which
just
control.
on?
You can
They-
do brightness, yeah.
They do have brightness, but there are only 6 of them. So you won't get a nice left to right.
If you shake your head and animate it.
But, I mean, that would be useful, because
We'll move the
if you're
system.
sending a really fast slope to one of the inputs, it might be helpful to sort of see how fast and back and forth you're going.
It's already running.
Okay, great. Yeah, so
I also do like, I think it is good if you can upload whatever instructions are to the computer, and then you can like disconnect your laptop and it still works.
yeah.
Like, I don't think we should be doing like live interpretation via the web interface.
Okay, so what I think we're going to do, we have 17 minutes left in the allotted time. I'm going to talk a little bit about my workflow when I build stuff like this and do the very first steps. I already did the first one, just tell an LLM to build a website because I just don't even really know how to do the first steps of doing that. But once you're there, then I can get involved. Yeah, if you want to toss me out for that, that's fair. And then I'm going to spend time afterwards over the course of the next few days building this out, and I'll use we'll figure out a way for me to get feedback from you guys and try it, because that would be fun. Because I love the idea. It's pretty cool. But I don't think I'm going to build it in 17 minutes. What we'll do, so this is Visual Studio Code, which is what I use for writing all my code for program cards. You don't have to use this. You can use any text editor, anything like that. I like it, like Visual Studio Code, because it lets me use a bunch of extensions. There's like an extension ecosystem, so you can basically, a lot of making code is like building on the shoulders of others and figuring out how to leverage stuff that other people already made to make your life easier. And Visual Studio Code makes it pretty easy to do that. It also happens to be developed by my employer. It's free. I'm not selling it to you. I also didn't make it. So what you're looking at right now on the left side is a list of files at the location on my computer. This is just like your File Explorer view. At the bottom is a terminal. This is just a different view, really, on this, where I can. It's just old school version of a file explorer. You can think of it that way. If I type ls on here, which means like list, you'll see nothing at all for some reason. Wait.
No, it is coming up.
Oh, there we go. So those are the folders that are available under my directory that I'm in here. And I can navigate around and I can run commands from the command line, which can be useful in these contexts. But it's exactly the same as if I were to, click on something here. It's just a more opaque interface for it. And then in the middle, I have whatever files I have open. I edit here, I save here, and then I'm doing some stuff through Git to do version control and keep track. Learning Git, I strongly recommend. It's really cool, very powerful. Really, it's just a way of, while you're working on something, saying, okay, I've done thing A, B, and C now, and I'm not sure about D, E, and F, but I might mess them up. So I want to put a point in time now so that I can get back to the spot that I was at after I did ABC, so I can toss out my garbage D, E, F and redo them. So that's something that I'm using here. I'm also using a tool that I made on GitHub here. That's called the computer card dev env, which if you're interested in getting into this stuff, it might be a way to help accelerate some of that. It basically makes it pretty easy in Visual Studio Code to spin up a little Linux virtual machine, a computer within a computer, if you will, that already has everything you need to code these. So you don't need to install a bunch of tools or a compiler or that kind of thing. It just automatically does it. And then I've added some commands in here that make building the cards a little bit easier. And what I'll be using, and what I always use to build a card for the workshop system, is this framework called Computer Card by Chris Johnson. That's the Chris that Tom was referring to, that I am standing in for today. And the Computer Card framework is basically this file that you put in your project. And what Chris has done is that he has done the hard part of doing some of this, in that he has, instead of dealing with these kind of hex memory values that are totally not human readable, where you go, okay, at this address, at 123 flash memory lane, there's something called proto2 rev 1. And you could write the whole thing by just pretty much using hex values or binary or whatever. And Chris has made it so that there's much more consumable things. You can refer to things like audio 1 and audio 2 that refer to the inputs. You can say, I have a sample, send it to the audio output, stuff like that. So that when we're building something like this, we don't need to think about what's the pin. I don't need to be looking at a diagram of the processing unit to figure out which pins are which. I can just add these kind of commands into my code. So I always include Computer Card in my stuff. And what you do when you're using that framework is you'll have a main file. And this one is the one that is part of the computer development environment. So this is just there. I haven't changed it. And what this does is it's a copy of the pass-through example. And I've set this whole environment up so that you can just write from this directory, you type the word make, and it builds it. So it compiles using what's called the Pico SDK. You don't need to know what that is. You just need to know how to Google it. And there's a huge community out there. If you hit issues, they've probably been hit already. And so that's done the compile. And then I can type make flash, I believe. Yeah, and it uploaded that to the card. So over here, you'll see that the behavior of this particular card that I have has updated. Oh no, I haven't plugged anything in. It said flash OK. Nice. I unplugged the card dramatically. And so I've actually done nothing. I have this card with question marks on it. There's our first computer-related silliness. This reports success, right? Flash OK. I was like, oh yeah, I did my job. All right, let's do it again.
Where's the USB cable?
Yeah, that was something I was going to talk about. Yeah, you guys might want to come around here and see what I've got going on here. You can absolutely use the USB cable to upload. This is called a Pico debug probe or something to that effect. I think they're about $8. And it's actually another RP2040 on a tiny little board, and you plug it in to the workshop. And this little tiny plug. Here, I'll turn it a bit so you can see. And all that this does, I don't really worry about it at all. I just plug it in, and then I don't have to do the dance that you do when you're uploading firmwares to the card where you, yeah, that dance. Yeah, where to upload a card file, usually you take the knob off, you push a little button under the knob, and then you click and drag a file on your computer. I can, now that it's plugged in, it'll actually work. If I type make flash here and hit enter, it's gone, and I've just, without interacting with the hardware at all, it's uploaded that to this, and now I'm getting the pass-through. So if I send, this is a very exciting card. If I send a sine wave into the audio input, and then I send the audio output to the mixer, you'll hear it. And I've got it FM'd, so that's why it sounded weird. It's just passing what goes in. But we can actually look at it. So let's do that. And you can see exactly what this card is doing. So a computer card program, you can just start from a boilerplate that already works. That's the first thing I'd recommend. Start from a thing that compiles and uploads, and then change it. So you can see what this is doing. It's more human readable thanks to Chris. There is, this is C++. If you've never written code before and you'd rather use something simpler, talk to me after this, and I'll show you Blackbird, which is where you can use Lua to do some things. To do something like this, unfortunately, we're not going to be able to do that. But in this C++ world that Chris has set up, you can do things like say audio out 1, and then just pass that audio in 1. And this is all inside this thing called process sample. Process sample is a bit of code, which I'll call a function, that gets run at a very regular interval of exactly 48,000 hertz. So 48 kilohertz, you're processing every sample. That means that whatever you put in here, you have something like 22 microseconds for it to finish on time before the next thing. That sounds scary, but it's actually quite a bit of time. And you can always cheat if you run out of time by slowing it down. Your example about the, what was it, a banana or something they were running audio through? A lot of people are not going to notice a 24K sample rate. Even a 12K sample rate, you can get away with a bunch. And that buys you exponentially more time. And that's kind of that's the technical limitation that's hard here. It's just like you have a very limited time to do whatever you're doing. This card, the entire process sample code is, I'm just going to lower this so you can see. That's it. And you can see it's just taking the audio input from input 1, passing it to the output 1. It's taking the audio output or input from 2, passing it to output 2. Same with the CV. Same with the pulse in and out. And then there's this logic that's set up to show the LEDs. So it'll turn, like, I think 4, 2, and 0. You'll learn the mapping of the LEDs, but suffice to say, I think it's just like 0, 1, 2, 3, 4, 5. Computers start counting as 0 most of the time, unless you're using Lua. Sorry about that. But so do elevators in Europe. So yeah, so 4, 2, and 0 is the left 3, and 1, 3, and 5 is the right 3. And so we'd expect the left side to basically render your switch state and the right side to render your knobs, which is, it's hard to see, but that is what it does. And all I'm going to be doing really like there's more to this program, but all it's doing really is setting things up and saying, hey, this is a computer card. Go ahead and do whatever is in process sample at 48,000 times per second. And that's what you're manipulating here. So for this card that we're building, I'm going to be trying to do as much as I can in the website because your computer is way more powerful than the RP2040. So I'll have to figure out what the right balance is. I don't know what that is. But what I'm thinking about is there a way I can send minimal information over the USB wire at a rate that feels responsive in both directions, because you can modulate the position of the frame. So the website needs to update automatically when you send modulation signals in. And you can interact with the picture and or upload a new one. So well, I guess we could kind of do it Etch-a-Sketch style. So maybe the minimum thing would be you can't really do too much other than upload a file in the web page, and you can see it, and you can see where the frames are. And then on the device, you turn the knobs, the frames move around, enhance, and you
That'd be very cool.
and you hear the output.
A picture with stuff zooming in and out on the browser.
Yeah, yeah.
Like that.
And then on the computer side, I'm going to just send over whatever minimal information we need in order to get the outputs that we want. And I'm going to process those in process sample and send out the outputs at the appropriate time. And then also I'm thinking about using the onboard screen, doing the same kind of thing that's happening here. I actually, almost all my cards, I think 4 out of 5 or maybe all 5 of my cards just show the state of the corresponding output, because there's 6 LEDs and there are 6 outputs on the computer module. So you can just say, oh, if this gate is high, then make that bright. And I found that at least in my testing, that's been very useful to see if, I should hear something right now. And so there it is. So I think that's an acceptable use of the outputs. It might even make sense here, just using it as VU meters. But I do like the idea of, I think it would be particularly cool if you had like your phone or something used as the camera and you move it around and you see the LEDs change. That would be pretty cool. Okay. I think.
Is it communicating over web serial, or like how does that work?
Yes. No. I don't know.
Okay.
Yeah. I'll have to figure that out. The thing I told the LLM was to use serial just because that's what I'm being most familiar with the most recent stuff I've worked on. It's fast.
Is there anything other than web serial and MIDI for that?
You can do HID. You can do, which would be the game controller. There's also game API.
Serial,
Pretty much, yeah.
there's no kind of magic fast.
No, unfortunately, not that I'm aware of. There's Ethernet over USB. I've considered doing that a couple times. I don't know how fast that is.
Could do web Bluetooth to the browser.
Yep. Yeah. I think I have enough to go down this rabbit hole. I won't, let's just see what the website that they build as a closer, because that's kind of funny.
Yeah. Can you share a link to that dev container too?
Absolutely, yep. And if you ever used dev containers before, it totally works. Code spaces totally works.
Nice.
For the nerds, to get this hooked up, I do have another terminal window open that's running this thing
Yeah.
on my Mac, but it's just a script that's in this folder. It's the start OpenOCD host, whatever. For the non-nerds, just pretend I didn't say anything just now. Just don't worry about it. I know you guys are all nerds. You know what I mean. Not you.
Dune, that thing you were saying about if you're working on something and you've got 3 things working and you want to sort of save that state and never go back.
Yes.
What did you call that?
That's called Git.
Okay.
GIT. Yeah.
And it's built into this.
It's just one of the core building blocks of software development.
It's what keeps the source code.
But it's built into VS Code. Like
Yeah,
you don't
it's
really
built
tell
in.
anything.
Yeah, basically what happens is anytime I change a file, this little button here on the left, I switched this over to my Git view. You can see it's already made some changes, right? Anytime I change a file, it shows up here. And what Git does is it allows you to do version control in terms of seeing the change. So this is going to all be green because it's a brand new file.
Okay.
So for someone who didn't know what they were doing, you could sort of basically problem solve your way through it.
Yeah.
As opposed to
Yes.
Rather than
no bunch of commands.
copying all code and asking GPT to
You can tell they use the Git for it.
Directory listing for.
Right.
Great. Okay. So what it's done, which is kind of funny.
I remember before Git.
As you can see,
SVN or whatever.
CBS, SVS.
as you can see, it shows exactly what we designed because LLMs are perfect and they just get it right the first time. It's at least there is a website that it kind of created that's just hosted locally now, and it seems to be just showing the contents of my my folder.
But it's an index somewhere.
There's an index, right? No?
It hasn't made
Or
maybe it's in the Dyski folder.
Yeah, you've got a web.
Oh,
folder in
that's
there.
okay.
There you go.
I think it's because
Oh shit! Here we go. Okay.
I think it's because that Python web server just served the folder.
yeah.
Okay. Oh yeah, right. Maybe I wasn't in the right directory. Okay.
Yeah.
Serial connection. Okay. I mean, image upload. Great. Let's upload a file. Let's upload this. No, not you. Let's upload this screenshot of another project I'm working on.
Wait, let's look at desktop nonsense.
Oh, sure. Yeah. This is all shit that I just like dragged in there so that this is what was on my desktop before I came to Toronto. Yeah. Let's use something from here. These are all screenshots of. Oh, this is from the development environment. I was testing all the cards, see what it builds. Pardon me, what?
Real pictures? This is code of code.
Oh, there you go.
Yeah, that's a graphic score.
Yeah, there we go.
What a programmer's desktop looks like. It's all screenshots.
Where's that code?
Ah, you called me a programmer. That's cute. That's
It's on screenshot, because, like, what did you do here? That's how it works.
okay, so we uploaded it.
Screenshot.
Interesting. So they made some assumptions, right? So I put in very vague things into, and you know, okay, yeah, I do use LLMs in my development. I don't trust the output at all, and
Never trust.
but and you always have to look at, you know, you're accountable for the code. If you were the person putting the prompt in, you're accountable for it. It could be by accident doing something really evil, and so you should really understand what's going on, but you don't have to write it. Like I don't, yeah, you guys know more about web dev than me. I just showed that by not clicking the index. But yeah, all I said was it has enough context. It'll use this workspace to know kind of what's going on. So I just said, I'm making a car that will connect via USB serial to a website that allows an image upload. Build a website. And it built this. Which does what I said. We added a lot in our design session after I did that. You know, it's a start. I think it's a lot more focused on the connection and that kind of thing. But it's at least like a starting place for us to go by. I think I'm just going to go kind of full screen with the picture and have a little bit of connect, disconnect. Maybe I'll figure out what the right protocol is. I have a feeling Serial is probably the best one.
Will it connect if you click?
Let's click it. I don't think so.
You haven't made it. It hasn't given you a UF2, has it? Hasn't
No.
given you a card.
No. Oh, web serial not supported in this browser. Okay, great.
Oh yes, sorry.
Maybe it'll prompt me if I'm in Edge. Hey, okay. So I can either connect my debug probe or use my Bluetooth thing, because nothing's connected, right? I guess I should see what happens. I don't think it's going to do anything. Does anybody have, oh man, I don't have the right cable in here, so I don't think I'm going to do it. Let's just pick one of these and see what happens. It says it's connected. It may just automatically say it's connected.
Well, it would try and send that serial to your, that's the debug port.
Yeah, so who knows what happened. Or if my debug board is still alive. Maybe not. Anyway, yeah, so what I'm going to do is start from here, build out that kind of screen interface that we talked about, and then build out the card side over here. And I'll be doing a combination of sending prompts into the GPT thing on the right and looking at the outputs and reviewing them. So I can like keep or undo those ones, and manually editing stuff depending on what we need to do. One thing that I didn't talk about that can be intimidating about this stuff and is worth mentioning is that the RP2040 is a fixed point arithmetic device, which means that instead of nice decimals that you're used to, it will use large integer numbers to represent those. Super annoying, but it's the kind of thing that once you get on the bike, it's not a big deal at all. The TLDR on it is they treat 4095 as 1. It's totally arbitrary, but 4095 is 1, and then 0 is 0, and then you just go up from there. It's really silly, but that's. Sorry?
Nothing confusing about that.
Nothing confusing about that. I mean, you know, the country that I choose to live in, you know, uses feet and stuff. I don't know. It's like there's no logic. I think that's it. Any questions?
What's the dev loop like? So you're just saving and then building and then pushing that?
Yeah. So I've got it set up so that I can. I would be like, let's make a change to the main file so you can see. Like right now, audio output 1 is outputting whatever's coming into audio in.
Make a mux. Make a mult.
A mult.
So
Yeah,
you
perfect.
just put audio output 2 is audio output 1.
Yeah,
That's
perfect.
mult.
Yeah, exactly. That's the one character change. Right? Okay, then I would hit save. And I would go down here. If I'm feeling lucky, I might do make flash, which will both build it and upload it. And now, if I switch the plug to audio 2, I should hear it again. There it is. Hold your applause.
There you go.
But that's, you know, that is it at its highest level. And then I would go into my version control and say, you know, remember this change that I made where I changed the main file and say, make it a mult.
But you can see how quick it is. You literally just hit save and then it's on the machine.
Yeah.
But if you have the little debug.
Yeah.
Yeah.
So here's like a totally ignorant question, because I've understood almost none of this.
Oh, I'm sorry.
No, it's okay. Every input and output, the audio, the CV, the gate, all of those jacks and the computer module, they all run to a computer, and the computer can reconnect them all in infinitely reconfigurable ways.
Yeah.
Mm-hmm.
But within those, so you can't change a pulse into an audio.
Right, it's fixed as a gate,
Yeah.
fixed
Yeah.
as a CV,
The
fixed as
CV,
audio.
the CV are just CV. The audio can also be CV.
Ah,
Yeah.
So you can have 4 CVs.
okay.
They're limited in terms of like the CVs, I suppose, are low pass.
And the precision as well. You can have
Yeah.
a much more precise CV on the CV ones.
And then
And are they still just left as in, right as out?
Yeah.
Can they all be in the audio?
No, they all have to be
It's
in
all,
or out. Yeah.
all split down the middle.
Yeah, the hardware is fixed.
You've actually got more to play with here than with Crow,
Mhm.
right?
Yeah. Though you can, I'm not sure if you've messed around with Blackbird, but yeah. So this allows more, in exchange for more complexity, you get more control, basically. But yeah, if you haven't messed around with this at all, like I'd encourage you, I can help you load the Blackbird card onto one of your cards and show you the public website where you can go just like type stuff and you can literally just be like, output to voltage A, and it'll just become that right away. And that's a great place to start. This is really like when you want to go deep and you want to build something more complex and you need to be able to calculate things faster than 50 times a second, say, or 100 times a second.
And Tom, do you ever think about releasing computer as a standalone module?
Yes.
Is it coming?
No.
Like when?
It is coming in the next few months. My hesitation has been because I really like it when people develop stuff that works in that context of the workshop system. And I feel like when people are developing for kind of random Eurorack worlds, it's a lot less compelling.
Any other thoughts, comments, questions?
Yeah, could you incorporate other external C++ libraries into it and bundle it all up? Like, we were talking about this whole image processing thing. Could you bundle like an image processing C++ library and use that?
As long as it can do, as long as it is compatible with the processor, then yes. Because of the fixed point thing, a lot of libraries might need some adapting.
Yeah. Okay.
It's not that floating point operations don't run, by the way. They're just very slow. And again, you have 20 microseconds. So,
But there's lots of that stuff around, like there's a speech synthesis library.
mhm.
You find an RP2040 speech synthesis library, you drop it into it. There's presumably that USB interface must use, maybe it's all just USB tiny, but yeah, I mean, when somebody makes a sort of 6-in, 6-out USB library, they're not writing that themselves from scratch.
Yeah, totally. And the like the braids card twists is, for example, I think it's mostly Emily's code.
Yeah.
Emily Gillet is the genius behind Mutable Instruments. There would have been some changes that needed to happen in order to get them over.
But that was a Arduino with fixed point, which is where that one works.
Ah, okay.
And the other mutable cards were all with floating point.
Oh, okay. Interesting.
So
I didn't know that.
What's the round trip latency like in Intel?
It's very fast.
Yeah.
Which is nice. Very, very fast. I don't remember the exact numbers. Do you know, Tom?
no, but there's not a lot going on. It's very it's very quick for that sort of stuff.
Yeah. So for feedback stuff, you can get, yeah. I mean, let's load BYO Benjolin on, just quickly, just real quick. This is a card that I wrote I think it was the second one I ever made. So the whole workshop computer repo is here.
Oh, so it's just like a big mono repo with all the cards.
Yeah.
Cool.
Yeah. And if you look at the main file for BYO Benjolin, I think it's like 400 lines. Yeah, 288 lines. That's very short. For reference, I think the Lua one that I made, Blackbird, I think is 6,000 lines. So this one is real small, and it's a Rungler and kind of chaos machine. But I think it gives you an idea of like what the latency is. I need to go over to it. One second.
Other than the mono stuff,
Mm-hmm.
have you heard of anyone else trying any other like higher level languages that to like target the workshop system?
So there's a guy using Rust,
Mm-hmm.
And there's a few people using MicroPython.
Okay.
Yeah.
Both of those can work on it.
Okay.
And I did stuff in Arduino, which is obviously not really a high language, but
Yeah.
you can use that.
What is the number?
Anything that, so basically anything that's.
Anything will run on RP2040 will run on this.
What is that max rainbow stuff?
That one you can't do, because that's a lot bigger. That's only for like full Raspberry Pis rather than
Okay.
Cycles.
Okay, so we'll do a noise send off. This patch I'm making is sending the output from a rungler, which is like some random stuff, a little bit like a Turing machine, and it's setting the frequency of an oscillator that is in turn patched back in to be recorded back into this kind of 1-bit delay. You can think of it as the shift register. And so that happens really fast. And then you get this loop. Oh, that's the input. Nice. This should work. And woo! Wow, the frequency response to this thing is not flat. So you can do kind of like Turing machine-esque things and it locks. This one in the code, I actually think I called it, you can see it somewhere in here. Somebody caught it on the Discord. The illusion of stability. It doesn't actually flip. It just doesn't, yeah. Anyway, but yeah, you can crank it up really fast. And it'll just stay there. And you turn the fine knob just a tiny bit. Yeah, so the latency's pretty low. All right, well, thank you guys.
Brilliant. Thank you very much.